All right, so let's start with half-life. All right, so we want to do a quick review on half-life. So let's start from a simple example, right? Let's say I give you a block. Let's set it up as a graph, right? Let's set it up like this, and we'll do a small plot one time. So I'll show you how to read off the graphs one time. So we're starting off with 200 grams of a radioactive element on the 0 day, and the half-life for this element is how much? 3 days? Let's use 3 days. All right. So we're going to just run through the concept of half-life, right? So half-life is the time taken to reach to half of the present element to the K. So for example, if you have a radioactive element and it takes 2 days for that radioactive element for half to decay, then every 2 days half of this will disappear. So on this 0 day, pretend that's the whole, right? After 2 days, you'll end up with half of it. Then that's half, right? After the next 2 days, half will go. So after 4 days, that's what you have left, right? What fraction is this? Anybody remember? 1/4 of the whole thing, right? So the fraction there is 1/4. And if you remember, 1/4 is 1 on 2 to the power 2. How many half-lives did it take to reach here? 2, right? Because we'll be on day 4, right? Hey, Grace? We're on day 4, right? So it took this here is the number of half-lives. Right? So there's a nice formula, 1/2 to the power n, that gives us an idea of the fraction left after a particular number of half-lives. All right? 2 more days, it will reach half again, which is 1/8. Right? That's the way the radioactive element will decay, and it will continue to do that until it gets real small. Would it ever reach 0? Would it ever reach 0? No. Right? So if you look here, let's say I gave you this radioactive element, right? Whatever it is. And the radioactive element has a half-life of 3 days. Then, right, in the corner here, this word is fraction left. Right? So after, on the 0 day, we had the whole fraction there, right? Everything there. After 3 days now, it'll be half of this, right? Because the half-life is 3 days. And half-life is the amount of time taken to reach half of the original present amount, right? Half of 200 is 100. All right? This is half of the original. So on the first half-life we have reached a half. So a half left. How much decay? A half, right? A half decay. After our next half-life, so that's 6 days. Half of this, right? Half of the present amount. The present is 100. So we'll be at 50. Right? And 50 is 1/4 of this. So it means after 2 half-lives, this is 0 half-life, this is 1, this is 2. After 2 half-lives, we are 1/4. How much decay? Right, which is 3/4. 3/4 decay, right? After next half-life, half of this, right? Which is 25, and that'll be 1/8. After next half-life, that'll be 12. Half of this is 12.5, 1/6. The nice thing about half-life is that these two things are always the same. These two things are always the same. After 3 half-lives, it's always at 1/8. That's okay? So I don't want to complete this table, but I want to figure out what happens on the 7th half-life. Could you fill this row out for me? Try to fill that row out to the 7th half-life. try to fill this row out here for this 7th half-life. Online, you all can message me. Let's see what you got now. Right? Don't forget I give you this up. 1 over 2 to the power of how much? We're trying to figure out 7, right? So I gave you this relationship here and I wanted to use it. Use that relationship there. Finish at 7th row, right? You also have to be able to go the other way around, right? I'll show you that now. All right, let's do oil writing. Go ahead, write it down. Let's do what you get. Please do work out 5 and 6, huh? Let's work out 5. Oh, we're about 5. Boy. Let's see what you got. Sure, anybody else next to you is to open them here. So this is 1 over 2 to the power 7, which is 1 over what? 128? Yeah. Right? And you have to find 1 on 128 of 200. How much is that? Oh, 21 days, right? 6, sorry, 1, 6, 2, 5, 6. Huh? 2, 5. 1 point? 5, 6, 2, 5. 5, 6. Oh, yeah, she's never come figures. Right? So you're finding 1 on 128 of 200. That's okay? 1 on 128 by 200 is this. 7 by this is that. All right? So while we're here, let's just do a quick little sketch now, because sometimes they can ask another graph question. So let's do a quick little sketch, and then from it we can find half-life, right? Let's do a quick little sketch here. 3, 6, 9, 12. Right. What's supposed to be the shape of this graph? What's supposed to be the shape of this graph whenever you plot a half, whenever you plot mass versus time for a radioactive element? It's supposed to be shaped like a curve, right? A decay curve, right? It's supposed to be shaped like this. Let's see. When it's 200, this is mass, right? And this is time in days. Right? When it's 200, that's on the 0 day. On the 3rd day, it was 100. On the 6th day, it was 50. On the 9th day, it was 25. Nothing coming out so good, but you understand? Then 12 is something, right? So it's to look like this. Right? It'll come closer and closer here. This is your decay curve for any element. Are you okay with that? That's what the decay curve will look like. But how do you read off half-life from it? We know what the answer is, right? The answer is supposed to be 3. How do we read off half-life from a graph like this? To read off half-life, you need to give them 3 readings, right? And then you'll find the average. Okay? So here's how you get the readings. Watch this here. To get the readings, you take 200, read off that. Take 100, read off that value, and you'll get 3. So your first reading is 0, 3 minus 0. Then pick a next 2 readings. Let's pick half of 100 is 50, right? So we're coming up here, and you're reading off that. Subtract 6 and 3, you'll get 3. That's okay? You can pick a next 2 if you want, right? You can pick 8, which might be our 4 or something, and pick 80 and pick 40. And then it should get the next value. That's okay? Are you sure? Huh? So all we're doing is this. Take a value, read it off, how long time it was at, then take half of that value, that's 50. Read it off, and then subtract. Do that 3 times. Any 3 you want. The value is supposed to be close. Then you add it up and find the average, and you get 3. Right? It wouldn't be exact. It wouldn't be this close. The reason this close was I just plotted, right? Okay. So if they ask you to find half-life from the graph, Raj, you have to find 3 values and then find the average, not just 1 value, right? Okay. And the value should be close. Right. Sometimes they like to ask the other way around. Right? So for the same question. All right, now let's change the question. Let's say a radioactive element fate is 1 on 64. Right? It took how many days to reach it? It took about It took 36 days to reach here. Right? So you have a radioactive element, Sherelle, and it took 36 days to reach 1 on 64. Did you figure out the half-life of the element? Try it. Try to see if you can figure it out. The first thing you have to do is figure out how much half-life it took to reach here. How many half-lives did it take to reach here? And then you can figure out the half-life. Okay? All we know is it took 36 days to reach here. Try that there, work it out in your book. And let's see. Right, that's your answer. Let's see what you got. right? So 1 on 64 is how long? 1 on 64 is 1 on 2 to the 6, so that's 6 half-lives, right? So it took 6 half-lives to reach here. So I just have to divide by 6. And I'll get 6. So the half-life is 6 minutes. Are you okay with that? Let's go again. Let's do a question. Can I share it, boy? Oh, we didn't balance the equation. All right. I like this question will give us the opportunity to revise alpha, beta, gamma as well. So let's take a look at Jan 2023. Jan 2023, do I share them? Let me start up the lobby. Do I share that here? Let's take a look at Jan 20. It's in the group. It's in the group. Jan 2023, number 6. Yeah, it's in the group, number 6. Come on, you want that? Come on, time, why not? Send the thing, girl. In message, no? I tell the message, no? I tell the message, that's how I do. Yeah, just message me, add the number, and I'll message me quick. Message me, and I'll add. I think we've done this paper already. I hope we can do it. The rest of the time. We want to send number 6. You do the last part, and then we're going to revise. No, we'll do the whole thing together. You do the last part for me now. Last part. Oh, yeah, the half like Right, only the last part there because we'll review the first part together. Do you remember to do this?
Yeah,
Anyway.
you're using formula.
Minus 4. All right. Finish? Yes. Part 2. Can you part 2? Coming back and go, we'll do that together, right? Oh yeah, work out this part. All you have to do is decide how long, what's the half-life? And how many days after you want to find out what you mean. How much days after? How much one half-life in those days? 552. Check it and see. Did you calculate and see? You have a 4. How much half-life it is in 552 days? How do you know, Ricardo? How much half-life is in 552 days? Really? Oh, that's how much days. What's the half-life for this element? Look at it, read it. 130 is the half-life, right? Right. If 130 is the half-life, how many half-lives would occur after 552 days? So you figure that out. What's on the board? How much half-lives after 12 days? The half-life in 3 days. What on the board? After 12 days, how much half-life went? 4. How do you get 4? Right? You divide 12 by the half-life, right? Can you do the same thing here? 4, right? And you figure out how much half-lives. What fraction is left after 4 half-lives? What fraction is left after 4 half-lives? Ricardo, you? Yeah, you do this whole thing for us. You confused? So you figure out the number of half-lives, right? 552 over 138 is 4. What fraction is left after 4 half-lives? There's a little formula I gave you. Right, fraction left. 1 over 2 to the power n, which is 1 on 2 to the 4, right? Right. So it's 1 over 16 of how much? 1 over 16 of how much? Why would you use the days? Read the question again. Read the question. Think a little bit. You'll get. Have you check out any answers online? Right. Multiply by 6.4 by 10 to the 6. What you got? What you all got? Peter, much you got? Why do you have to Peter, answer. Yeah, how much you got? 4 by what? 4 by 10 to the power 6. Alright, so that was real bad. Let's go again. Forget the rest. Let's just focus on half-life. So you'll follow what went on there. I took the half-life and I divided to find the number of half-lives. Right? Anybody can give me a little general idea of what it did here? Generally. Don't use the numbers. Let's tell me generally what I did. To get what? To get the number of half-lives. And after I got the number of half-lives, what I did? No, not multiply. I found what? I found the fraction left by using the fraction left formula. And after I figured out the fraction left, what I did? By the initial amount. Right? So the initial amount could be in grams, it could be in nuclei, it could be in anything. Alright? So I want you to understand the concept, right? So I found the number of half-life after the time period. After I figure out the number of half-life, I found the fraction left. Okay? So what you should do is create a little chart. So is it not to the power of 5, not 6? 6.4 divided. Yeah. From to the power of 5. It's 6.4. Thank you. 4 by 10 to the 5. You need a calculator, right? Use the phone, just plug in the long thing. Thank you, was our online that there. Thank you, quick. Oh, Katrina, yes. I saw yours too. Right, so earlier, I want you all to be able to grasp the concept, right? Here's what I do it. Take a look and go there. But what I'm doing is, watch here. Look and go there earlier. So if I know the half-life, fate, that's okay. If you know the half-life, come, watch here. If we know the half-life, we're using the half-life to find the number of half-lives after. After we figure out the number of half-lives, we found the fraction left. We found the fraction left. 1 on to the end. After we found the fraction left, we found the number of nuclei left. All right, so that's a little general thing that we follow. All right, let's do our next one. Kalina again, Eden. Adele, you're sending any answers, Adele and Kalina. Oh, Kalina was online? Yeah. And Shannon. Right, true. Shannon don't send anything, boy. Alright, forget this one here. I give all this was green here. I like this one. Try this one here. Ignore balancing the equation. Right? You come back and do that. I want to make sure you all follow half-life. Part C. Try part C. No, Adele, the last question, Adele. That didn't note at the beginning of the class, Adele. Right? Work out this one. She might work it out. We're watching your phone there. No, I ain't said it. Take it on the board. A picture. Read part C alone, right? Read part C and let's try to figure out. Yeah, you have to calculate the half-life. So look at the flow chart from the last one and you're probably going to reverse. Oh, okay. But do what you said in WhatsApp, you can just type out the answer, right? Right there. Like if it's 4 or 5, just send that. If it's too long, I won't answer. Shannon. Shannon, I'm going to call him one now, eh? But that message Shannon don't work. Try that there. Right? What are the key things? Remember, the key things are this is the initial amount. That's like the first mass. After 15 hours, that was the final mass. You have to figure out something happened there. Something happened there. How many half-lives does it take to reach 250? Right? I'll pick on somebody else. Let me see who looking at lost fish. Check out Joy there. Check out Joy. Yeah, Joy, I feel like they do this one. Between Joy and Faith. Who? Faith, why is Faith so long? Huh? You can do it in 3 steps or 1 step. It can be done in 2 steps. It can be done in 3 steps. 4 according to how you write. It can be 9 steps. It can be 42 steps. So you can figure it out. No, the question asks what is the half-life? So you figure out part of it. No, you didn't figure out part of it. Something missing. Fritz. There you go, Fritz. Make a proud here, Fritz. So Fritz, what fraction is left after 15 hours? What fraction is left after 15 hours? Huh? 160? How you get up? You get that sound. How you get up? You divide 250 by 1,000 and you got 160. Check it back again. Pardon me? Yeah, but you wouldn't get the fraction left. What is 250 and 1,000? A quarter. How many half-lives to reach 1/4, Fritz? 2. Right? So it takes 2 half-lives to reach here. Right? So it takes 2 half-lives to reach 15 hours. Are you okay with that, Fritz? So Fritz, if it takes 2 half-lives to reach 15 hours, sorry, but 15 hours to reach 2 half-lives, what is the half-life? It takes 15 hours. It takes 15 hours to reach 2 half-lives. What is the half-life? Huh? A half by, all right, yeah, 15 and Simeon. That make any sense? Sure. So the half-life is 7.5 hours. You get that one? Carry on. Yeah? Huh? Anybody what? Sorry? Yeah, I can look, yeah. All right, so it's important that we can identify what we have. What we have is after 15 hours, it reached 250. So what does that 250 represent? That 250 represents 1/4 of the original amount. How long does it take to reach a quarter? 2 half-lives, right? Use the formula 1 and to the end. Any questions online? Are you okay with this, Ricardo? Huh? Why? Confused about what? Read the question over. Huh? All right, so Ricardo, let me ask you some questions. Right, so what will be the important things there? What does that 1,000 represent? Which is the initial value, first value, right? And then they said it took 15 hours to reach to how much? So it took 15 hours to reach 250. So we need to figure out how much half-lives it took to reach 15 hours. That makes sense? You want to get to 1 half-life. Okay with that? So to tell you, that 250 counts or whatever it is, right? That 250, right? Is what fraction? Out of the 1,000. How much half-life does it take to reach a quarter? Right. So how much half-life is that? Based on the formula. What is right? And it's 2. So if 2 half-lives taken 15 hours, and you get 7.5. So that's the concept that we use. Okay? Try to figure out how long it takes to reach 250. And we figured out it took 2 half-lives. Let's go again. Let's make it get this one right. Try this one here. Ignore this, right? We're not doing any reactions today. Write down all the important info. Write down what this is. And write down this. That's the way you get figure out. They ask what fraction is left. Online message answers right here on Zoom. Let's see what you get, right? Right, good job, Quinn. Good job, Quinn. Good job, Katrina. And Shannon, you said something nice. Somebody says 7-ish. Josiah. So all they give it hours. They give you half-life is 18 and time is 90. So what's the first thing you should try to find, Ricardo? What's the first thing you should try to find? Divide it by 90. But that's time. Well, why divide time? Why divide it like that? What does that 90 hours represent? Number of time passed, right? So what we normally do with the number of time, with the time passed. Think about it again. After time passed, we always try to figure out how much what? How much half-life go on, right? So what you would do, Ricardo? 90 hours passed. How are we going to figure out the number of half-lives? You do ever divide the time by 2, it's the mass or the other thing to divide by 2. Faith, yeah, saying something. Someone will say. Yeah, Ricardo. Huh? I had. So someone, what you would do? John, someone half-life is, right? Time it takes for element to decay. Half of it to decay. Like first thing I said at the beginning of the class, right? So after 18 hours, what would happen to the element? Half of it will decay. After next 18, what would happen? So how much time passed now? And this question. How much? So what you have to figure out? How much half-lives in there, right? How you gonna do that? Hey, what's up, passing up? Yeah. How you would do that, Ricardo? It do overthink it, it's real simple. One cookie is 18 hours. It's $18. How much cookies is how much cookies you will get? $90. Divide what? Right. How much you get? Divide 90 by 18, right? How much you'll get? 5. So therefore 5 half-lives go on. Right? So how you get the fraction? 1 over 2 to the 5. Right? To do it real simple, don't overthink it. So that's 1 on 32. Correct? Let's go again. Anybody confused? Joy? Catch it now? Anybody confused? Shiva, you good? Next one is yours. You are right. Or they can play rock, paper, scissors and decide who's getting it. There's no favorite here. Think here. Last one. Oh yeah. Sure, man. Oh, no one, you're gonna sit up by yourself. I'm gonna create an island here for you, so you can't go nowhere. Right. Try this one between Shiva and Raj. You're going to do rock, paper, scissors. No, just one. Who win this one? Who win? All right. Go. Yeah, Raj, it's yours. Take your time. Read it through. Read it through. See what information you have. They want to get the probability. It's a very tricky question. So let's see how far we can reach. You're trying to find the probability that it happens. So the same half-life. It's the same half-life question, but the answer is different. 1 gram of living plant is about 16 disintegration per minute. It is from there, it now reached 1. So it went from 16 to 1. Try to figure out what something that represents, and they give you the half-life. Try it on there. Right? Try to figure out something and then figure out something else and then figure out something else. Right? We gotta get the age of that plant. So it went from 16 to 1, right? So what fraction did it reach right now? It was at 16, then it reached 1. What fraction is it at right now? 1/16, right? How long does it take to reach? And then figure out. And I give you the more hit. Hurry up. Come down here. Trouble? Yeah. And I'm not good. That's time. That is age 1. What fraction? Right, message answers. Let me see. I've seen one here so far. Right, so to go from 16 to 1 disintegration, it means that it's now at 1/16. Correct? How much half-life is 1/16? 1 and 2 to the 4. So the number of half-lives is 4. So what's the age, Cheryl? What's the age? If the plant is 4 half-lives down the road, what will be the age of the plant? Huh? How you get up? Go ahead and tell me. I want to know. Oh, yes, fine. Huh? What is the half-life of this element? What is the half-life of this plant? Look at there, it told you. 5,000. So the half-life is 5,500. So what do you do now? So you what? Why would you buy it? How would it be less time? Right? It will be multiplied by 4. Right? That's what, 22,000. So the plant is 20,000 years. And this is the way carbon dating this work, right? Simeon, you got up? Are you okay with that subject? Right? So we can use this carbon dating here to find the age and thing of the plant, right? Give it up. Now you are online. Are you okay? So next day we'll continue with radioactivity, but we'll do Einstein's energy mass.